Hi everyone. Yes, I have a question here. It says a sound wave has a frequency of 500 hertz and travels at the speed of 340 meters per second. Now we should calculate its wavelength and explain what happens to the wavelength if the frequency is doubled. So let's see the conditions surrounding this question. This physics for you. Conditions are very important. Frequency is 500 hertz, so F is 500 hertz, and it travels at a speed. There is a speed. V is 340 meters per second. We should calculate its wavelength. Wavelength is represented with the symbol lambda, and that is to be found. Then they say we should explain what happens to the wavelength if the frequency is doubled. Okay, so let's first work out the wavelength. Uh, the equation that connects speed, frequency, and wavelength says that velocity is frequency times what? Wavelength, right? Frequency times wavelength. Okay, so if we are looking for wavelength, then we can make wavelength the subject of the formula. So wavelength is going to be velocity divided by what? Frequency. And if velocity is 340, frequency is 500, then what are we going to have? Let's use our calculator. Okay, so we are going to be having 340 divided by 500. That gives us our lambda to be 0.68 meters. So lambda is measured in meters, right? Okay, that is the first condition settled. The second condition says you should explain what happens to the wavelength if the frequency is doubled. Now, the condition is that since velocity is frequency times wavelength, therefore means that if I'm looking for frequency, it will be velocity divided by wavelength. So let's look at the relationship. Frequency is directly proportional to velocity, but frequency is inversely proportional to wavelength. Frequency is inversely proportional to wavelength. So what this condition means is that as frequency increases, wavelength does what? Decreases, and vice versa, right? Okay, but then there is a condition. Since this happens is that frequency, if you look at frequency here, is very high, right? 500. So as frequency increases here, that means the first point of contact is that the wavelength must what? Reduce, so it can never be this value anymore. But then there is a standard condition that says that when you double your frequency, then you are going to have your wavelength. Yes, when you double your frequency, you're going to have your wavelength. We have already established that as frequency increases, wavelength decreases, right? So if you double that increase, you have to have the what? You have to have the wavelength. That's how it is. So double the frequency that's already increasing and half the wavelength that is already decreasing, you still have this equation. So this is how it is. So whenever you double the frequency, then you are going to have the wavelength. Yes, that's a condition. So if you have further questions, you can ask. But for now, I'll draw the curtain and call it a goodbye. See ya.